Hey YouTube, welcome to Darkchild Industries YouTube channel. This is our first video, so figured go through, talk about two of the four vehicles that probably see on the channel the most. First two up is going to be the one behind me here. We're also going to be going over this one, mostly about where they're at right now, what we're trying to do with them in the future, kind of fabrications needed, and generally what the end goal is, why we're doing it, and maybe some of the timelines, especially for this one here. This one's on a little bit more of a timeline than this one back here. So that being said, let's get to it. So I figured we'd go over to pickup first. All right, so this is seeing back here, this is 68 Power Wagon, all steel tilt front end, custom independent front suspension. It's sitting on a ladder bar and coilover rear suspension. About 90% of this truck's been hand built in this garage. PPG jet black paint. Sorry, it's a little filthy. We've been doing some fabrication here on the engine stuff I'll show you here in a second. Custom fuel tank, 16-point roll cage, methanol injection. All that stuff back here is air-to-water system, which I'll show you here when we get up to the front. Fuel system, custom fuel tank, Twin A1000 fuel pumps, all Aeromotive fuel system, Earl lines, Jags fittings, just best of the best, pretty much with this truck. Father-son project, been working on for the last about 15 years. It's always just been constantly evolving from a 500 horsepower stock four-wheel drive pickup to where it is now, where right now we're estimating it should be about 1,400 horsepower. Getting to the interior here. Right now, as you can see, sorry for the wiring mess. Right now, we're in the middle of updating with the MSD grid, precision performance shifter, factory truck seats. As you can see, there's a little bit more to cage work, custom switch panel, custom gauge cluster, all autometer gauges, stock steering column, more custom switches. But generally, the idea behind this is we just want to be able to have a fun truck, something that can be driven on the street, go to car shows, something like Carlisle or Columbus, not overheating traffic, and just generally be a fun time. But then when we decide that we want to turn it up, go to track, guys with the Demons and the Hellcats and the new ZL1s or almost anything that lines up next to us, we have a good chance of running with them or outrun. Alright, so I've been showing the engine on the camera here a little bit. Guess everybody's starting to wonder what the heck is in here, because this is not your standard big block Mopar. Alright, so we'll start on the driver's side. Alright, so down here, 540 big block, World Products steel block, K1 Technologies crank, K1 Technologies rods, diamond pistons, Indy 440-1 heads, full MSD ignition, Be Cool radiator, and of course everybody sees the giant Pro Charger. F2 Pro Charger, just put it on over the winter. Right now we have a 38 tooth pulley on there. Not quite sure where that's going to be at boost wise. And just like everything else on this truck, everything's custom made. Good friend of ours built the custom headers. Salad bowl intake. Yes, I said salad bowl. That actually started as a $10 gold Target special. And we work our way back here through the custom intake all the way up to the PT2000 intercooler and the Pro Charger big red pop-up valve. All the Century for the on-meter gauges. Had to modify the intercooler over to the winter because of the way that we are routing the supercharger tubes. Custom tubes built in-house. Jet Hot did the awesome coating for us. Absolutely love it. Very show quality, and absolutely does an amazing job of dissipating the heat. I will be posting sound clips in a later video when we get this truck out. Just finished it up tonight. Twin spoil fans, and I know another one that everybody always asks about is this hood. A lot of people think it's fiberglass. Nope, all steel. In fact, everything on this truck, for the most part, is original steel. This front clip here was built out of the original hood, the original front fenders, and part of the original core supports. It's heavy, but we can technically say this is all original steel. And you can see here part of the original fenders. There used to be a line that goes right here on some of them. And because we blended this in with the cowl, that's all just one giant piece now. So pretty cool little truck. Looking forward to posting a lot of it. And hopefully we'll get some track time soon. All right, so the next one that we're going to be going over in this video is the other hot rod that I showed earlier. It's a 67 Dart. It's my personal car. And as a matter of fact, right now, because I'm a senior at Penn State studying for engineering, electrical mechanical engineering, we will be using this car as a basis for our group's capstone projects, which is where a lot of the idea for this YouTube channel came about, is to document the process, the engineering process, a lot of the CAD stuff that goes on, a lot of the machining, and just the general build process that goes on with this kind of work. So I'm going to turn the camera around here, and we're going to go ahead and go over the car currently, go over what it's meant to do, go over what the senior design project is supposed to do, and generally about why and how we're accomplishing the project. All right, so the 67 Dodge Dart, unlike the Power Wagon, this is not all steel, it's not all original metal. Fiberglass fenders, fiberglass hood, fiberglass bumpers, as well as a fiberglass deck lid for lightweight. Fuel cap. We'll pull the deck lid off here in a little bit. Look down to the black abyss there. Alright, so what makes this car tick? Alright, so we'll get into the interior first. Again, just like the Power Wagon, roll cage, full set of autometer gauges. Unlike this one, some things do not match, and that was because when we bought the car, some of the gauges came with it. So why spend more money when you don't have to? Full Kirky seats, Kirky Touring, G-Force safety harnesses. Show some of the carbon fiber and tube work back here. All this tube work back here are the little tubes. That houses all of the electricals going from the interior to the trunk. So there's no need to run cables underneath the car. Window brace. The back windows are full Lexan. They're the only Lexan pieces. Nice solid thunk. Alright, so as I said, fiberglass hood, arrow catch, hood pins hold the front of the hood down, as well as all these little DUS fasteners, which I will show the underside of the hood. Once I get the hood open, we run a bunch of DUS fasteners down the side of the hood, help hold the hood down, especially at high speeds. Get the hood on here. Alright, so here we go. Much like the Power Wagon, big block Chrysler, except this one has a factory iron block. 1970 casting, came out of a Plymouth Roadrunner. Full MSD ignition, K1 Technologies crank, K1 Technologies rods, Keith Black nitrous pistons, 10 quarter 1 compression, Indy EZ 295 heads, as well as a dual plane intake with a Holley 950 HP full Magna fuel system compared to the Aeromotive in the pickup, as well as a full MSD ignition. Electric water pump, Be Cool fan, twin Spall fans on a custom built shroud. And both the Dart and the truck both run a custom 727. The Dart has a straight cut first and second gear, while the Power Wagon here, it's an older build, older transmission build. A&A Transmissions built it. They quoted that it is full straight cut gear, 300M input output shafts, which is same material that they build 50 cal barrels on Abram tanks out of. And it has a custom diesel mechanical diode torque converter. So in the 727 in the Dart, it is also filled with a bunch of A&A parts, because generally they're about the best that you can buy when it comes to 727s and Chrysler 904s. It does not have all the fancy stuff that one has, simply because I don't quite make the power or weigh as much as the truck does. But I do have a PTC torque converter, right about 4,000 stall tag. It's got a grinder, manual valve body with a trans brake. That runs a A&A valve body. Both run deep zone fans, of course, because you need all that extra cooling. And both run a built 9-inch. Dart has a Mark Williams housing. The truck has a full Moser built 9-inch. Both run 389 rear gears. And as you saw earlier, Dart runs full Wilwood front and back. Same with the truck. Like I said, lots of similarities. So lots of data sharing, especially when it comes to tuning and what certain parts may like. Suspension wise, while the truck has a custom IFS, the Dart, being a little bit more popular of a chassis, we run a full RMS coilover suspension. Absolutely love it. Makes this car turn and just drive like a new car. Ladder bar rear suspension with coilovers. Absolutely love it. Drives perfectly well on the street. Oh, another thing on the rear ends, both the Dart and the Power Wagon both run a spool. And through all the street driving, never had a problem with the spool, other than trying to parallel park these. Alright, so those are the vehicles. Those are the two hot rods. Now, the Dart, as I said earlier, is part of the senior capstone project for me. So we'll get into that next. All right, so with the engineering design project that we have for our major, which is electrical mechanical engineering technology at Penn State, we have to have a mechanical aspect, we have to have an electrical, and we have to have a programming. Cover all the bases that we had for the last 4 years. So we'll get into each individual part, we'll get into what each individual components are doing for each individual system, and a general idea behind why we're doing this. So the general idea of this project is we're going to have a active aero wing, where depending on speed and depending on how the settings are, we can either have a wing that goes 65 degrees, about 160, give or take, or we can make it whatever angle we want. The reason for this is at about 140, we can feel the back end of this car start to become a little lively at the top end of the racetrack. And currently, we only do quarter-mile stuff. Eventually, I want to move into standing mile and half-mile stuff. So, you know, we're going to be going a lot faster than 140. And also, this big block probably is not going to be the final engine. It may get nitrous for now in the future, or we may go ProCharger. I do have an F1 RSN here that I'm not currently using. So, don't know what we're going to do in the future as far as power. Currently, the car makes about 736 horsepower, 712 foot-pounds of torque on pump gas at the crank. And, well, you know, hot rodders, once we get a little bit of taste of horsepower, we always want more. But, so this is more of a safety thing. And also, the wing is also going to act as an air brake. Now, in order to control the air brake, we're going to keep it completely analog because it's safety. I don't want to be dealing with Arduinos or PCMs or anything like that to control my air brake, especially when I'm having to use it as a brake in addition to the parachutes that are going to be going on the car, which I will show in a later video. So, airfoil, active aero wing for speed. That covers a good majority of the project. We are going to be rewiring the car. We are going to be updating the wiring harness in this car. Already currently, it is a custom harness. It's a 1-point ground, which means the body's not grounded. There's no grounding components to the frame. There's no grounding components to the body. And the battery's not grounded. So everything goes through a ground bus. Everything goes through a power bus. That allows us to control the electrical flow, current flow, a lot better. Haven't had any problems with the car, electrically wise. And I love it. But I think it's time to update it. It's 21st century PCMs. You can get data logging. You can get circuit analysis. You can get circuit feedbacks, like that. So we're going to run a ECU Masters PMU. I will show that in a later video. We have the one that does data logging. That allows us to use different shock sensors for determining the travel of the suspension and how we can optimize the launch of this car, especially since it's on trans brake. And we have the MSD two-step modules, so we can make this car launch hard. Right now we foot brake it a lot because it's more comfortable for me to foot brake it. But in the future, in order to go faster, especially with the speeds we're trying to go into ET that we're wanting to run, the trans brake is going to be very helpful in doing that. So with the airfoil and the air brake, we talked a lot about the electrical side. Now let's get into the programming. For the programming, we're going to be using a Arduino Mega and an Arduino Uno. The reason we chose those is the amount of space, memory space they have, the amount of RAM they have. And generally, when you look at the Arduino community, there's a lot of information out there, especially for guys like us that are trying to use electrical components with them. So in order to articulate the swing, we are on the speed side, not the pneumatic side. We are using twin 450-pound actuators. And the reason why we chose electric actuators is they're relatively inexpensive, they're easy to work with, and they can generally be very quick, and they're really easy to modulate. So you can track the distance, you can tell it how far to extend, how far to retract with ease. So that's the reason for running electric actuators over run air cylinders or hydraulics. That and the electric actuators were the least in weight. They are the lightest. This is a race car. This is a high performance vehicle. We don't want to be adding a lot of unnecessary weight, which is another reason for getting rid of the current wiring harness. Going with the PCM is we're hoping to be able to cut some weight out of it by not having to run so many signal wires, so many ground wires, and also not having to run so many big 2-aught wires throughout the car. So programming wise, that's a lot of my group members. There's 3 of us. One of them is going to be doing a lot of the Arduinos stuff. The third is going to be helping him and helping me, going back and forth. But I'm going to be doing all the PCM wiring and all the PCM programming. So he has all the Arduino to worry about. I have all the CAN bus stuff to worry about. Seems to be even 50-50 split as far as programming goes. We're going to converge on the wiring. He's going to help. They're both going to help me run the wires, make this nice, run all the wires through AN fuel lines to give it a nice, clean, classy look that matches all the air fuel lines in the car. All right, so last but not least, it's going to be the mechanical. The mechanical side of things is going to be mostly related to the frame, the mounting system, and all the little systems that come about when building the active aero wing and mounting the air brake, as well as moving some of the parts around in the car to get a better weight distribution or simply just cut weight. One of the biggest things that we're going to do to cut weight is these glass, the windshield back glass. Going to be replacing them. The rear window's going to be some like an optic armor. Don't know what we're doing for the front, but right now we're estimating that between the front and rear windows, we should be able to shave about 50-60 pounds out of the car. And we'll go over this in a later video. All the little areas that we're going to be doing to cut the car's weight down for performance reasons and also efficiency, and because this car is just way too heavy. Right now, without me in it, car weighs 3,620 pounds. Similar cars with similar build styles, they're down into 3,000, 3,100 pounds. That tells me there's about 400 or 500 pounds to this car that should not be there. Which, we knew it when we built the car. There was a lot of stuff that we did originally to get the car running, or we just simply didn't have the skill set to cut the weight and we had to build stuff a little bit heavier. But now we have more skills. Now we have a little bit better machinery here. We're going to be going back and we're going to be redoing a lot of stuff. All right, so mechanical wise, custom frame in the trunk. I'll pop the trunk off here in a little bit and I'll show you what we're working with as far as the trunk frame. But most of the mechanical is going to be in the trunk, mounting this wing, mounting the electric actuators, mounting the air solenoids, the air tank, which we will not be using a pump. We're going to be using a air fill, similar to like a tire valve. And the reason why we're doing that is this wing is mostly for track use. I mean, can we turn the wing on when we're on the street driving it? Yeah. But most highways aren't fast enough to even require it. And on top of that, unless we're getting a better fuel mileage out of it, it's just causing unnecessary drag at highway speeds. And the air brake, it uses too much air to be used constantly on the street. Will burn out the air solenoids by trying to use them too much on the streets. So they're just going to be a track use only item. So I'm going to get this trunk off and I will show you guys what's going on in the trunk, kind of what we're thinking, and some of the challenges and the problems that we've already run into and some of the solutions and the fixes to this. All right, got the trunk lid off here. Show you guys kind of what we have to work with as far as space goes. As you can see, already got a fuel tank in here and battery box. And we currently have a Aeromotive pump controller so that we can run these big magnet fuel pumps long distances, don't have to worry about heating them up. Right now, as it sits, all this is going to go away. Build a new fuel tank for this, simply so that we can move this fuel tank further up inside. All the wires in here are going to be going. Battery box, may keep it there, may move it up front, don't know yet. Got to put the car back on the scale, figure out the best spot for the battery. And as you can see, don't have a lot of space to work with. But the main gist of how this frame is going to go is we're going to be mounting a plate here, right behind the taillights. Behind the taillights, run downrigger down to here. And then we're going to be running several outriggers to the frame. And then Everything else is going to be based off those 3 bars. Make it compact. Air solenoids are going on the bottom, underneath the floor. We are going to be putting a new floor in this car. Right now it's just sheets of aluminum. Hopefully we're hoping that we can run some like a carbon fiber. Again, cut weight and also increase the show capabilities of this car, because this is a street car, race car, as well as a show car. So this is kind of what we have to deal with. In later episodes, in later videos, we will document the build process of the fuel tank, thought process behind there, taking the measurements, designing it, getting it cut, and installing the tank, as well as all the rest of the fuel system, relocating the fuel pumps, and doing the design and fabrication of the chassis for the wing. So there you have it. Little gist of the project, little gist of the Powerway, little gist of the Dart. Like I said earlier in this video, this is a senior capstone project. Stuff we're doing with the Dart, so that means there is a time limit. And for us, because this is a race car, we do want to get to a track to test it. That means that we have to be done. I'm hoping to be done with this beginning, middle, sometime in August, before our last semester starts in the fall here. So with that being said, look for a lot of YouTube video updates over summer. And also keep an eye out on my personal Instagram, BeatArt67, because I'm going to be posting a lot of updates there. And also check out the new Instagram for this YouTube channel that correlates a lot of the material. Darkchild Industries. Both the links are going to be in the description. And I hope that you guys enjoy the future videos. I know I'm going to. I'll see you guys later.